Hi folks, Mr. Dell here. We are looking at solving equations, but specifically equations that contain either decimals or fractions, or sometimes even both, and ways to solve those equations without really getting bogged down by the decimal or fraction operations. So something known as fraction busters or decimal busters. So here we go. I'm pulling this question from this is CPM, and it's course 3, and this is section 7.2.3. Okay, and I'll rewrite the questions, and then we'll rewrite the equations, and then we'll go through the process. So let's just go through each of these. So we've got for each equation below, solve for x, and then check your answer. So solve for x. So A is 10 times the quantity of 2/100ths x minus 1/100th, and that equals 1. So first thing is I before I utilize decimal busters or fraction busters, I always have to distribute. It gives me a better sense of what I'm dealing with. So distribute first. So in this case, we'll distribute the 10, right? So the 10 is in front of the parentheses. That means distributive property. So you multiply them times each one. When you take multiply by 10, remember that moves your decimal point, making the number bigger, right? You're making it bigger, so you move the decimal point to the right once, because there's 1 0, it's 1/10. So we'll have this in this now, it'll be 2/10 x minus 1/10, right? So it's moved that decimal place once when I multiply by 10, equals 1. So at this point, I could keep solving and deal with decimal operations, but I'm going to now use decimal busters, which means I want to find something that I multiply each of these terms by that causes the decimals to actually go completely away. Well, you notice when multiplying by 10, right, that moved the decimal place once over. Well, I just need to move those decimal places one more time. So I'm going to actually use the decimal buster. So this is my decimal buster, and my decimal buster in this case is 10. Sometimes you may use 100, sometimes 1,000. It just depends on how many decimal places you want to move. So by multiplying by 10, I multiply remember, by multiplying by 10, I'm multiplying every one of these numbers by 10. So it's 10 times that. It's then 10 times the 1/100th or 1/10th, and then it's also 10 times 1. So every one of them gets multiplied by that initial 10 that we put in there. So 10 times this moves the decimal place once, becomes 2x, minus 10 times 1/10 is just 1, moves the decimal place once, equals 10 times 1 is 10. Now I have a nice equation without any decimals. So I just follow the process. Add 1 to both sides. We have 2x is equal to 11, and then divide both sides by 2. And therefore x is equal to 11 over 2. You can either say 11 over 2, or if you wanted to, you can write it as a mixed number, 5 1/2, or even 5.5. So there's A. So let's look at B. B, its equation is 1/3 x minus 6 equals 8. Okay, there's no distributive property to do, so I'm good to go. But in this case, I'm thinking, do I want to deal with a fraction, or do I want to use fraction busters? So I'm going to actually, in this case, use fraction busters, since that's one of the topics here, to make sure we know how to use busters. Fraction busters. So my fraction buster, remember, is the common denominator. Well, there's only one fraction. The denominator is 3. So I'm going to multiply each term, right, by 3. I'm multiplying all of that entire equation. So I'm multiplying that entire equation by 3. So I have a 3 times. So it's 3 times 1/3 x minus 3 times 6 equals 3 times 8. I'm multiplying each of the terms by 3. So 3 times 1/3. What happens when you multiply 3 times 1/3? When you multiply a whole number times a fraction, put the whole number over 1, and then you can also diagonally simplify, right? I can divide all of that by 3, right? 3 goes into 3, so that becomes a 1, becomes a 1. So really, I end up with 1 over 1, which is just 1x. Minus 3 times 6 is 18. equals 3 times 8 is 24. Now all I got to do at this point is just add 18 to both sides. And I have x is equal to, let's see, that's 32, 42. X equals 42. Right? It did say in the directions to check your answers, and checking your answers, I want to just maybe just show this one, is taking that number that you got for x and plugging it back into the equation to see if it works, right? So what does a check look like? When you're checking, you're going to take, so it's 1/3, instead of 1/3 x, it's 1/3 times 42 minus 6 equals 8. So that was the original equation, but now my x is 42. So 1/3 of 42, right? So basically what is 42 divided by 3 is 14, and 14 minus 6, does it equal 8 is the question. 14 minus 6, yes, it does equal 8. So it checks out. So 1/3 times 42 is 14. 14 minus 6 does equal 8, so it checks. So that's how you check it. You just plug it back in and see if it works. All right, let's keep going. So I'm looking at, where am I at? Here we go. Let's look at C. C is x over 3, or x divided by 3, plus 1 equals x divided by 4 minus 1. So that's my equation. So again, in this case, I'm looking at, I have some fractional terms. So I'm going to use fraction busters. And what is my fraction buster? Remember, fraction buster is the common denominator. So my denominators are 3 and 4. So the common denominator of 3 and 4 is 12. So I'm going to multiply everything. I'm going to multiply this entire equation by 12, right? So I'm multiplying each of the terms by 12. So it's 12 times x over 3 plus 12 times 1 equals 12 times x over 4 minus 12 times 1. So I'm multiplying each of the terms by 12. And when I multiply by 12, again, remember when you're multiplying a whole number times a fraction, you put the whole number over 1, and then you can cross simplify, diagonally simplify. And in this case, I'm going to divide by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. So this term now, right, the busting of the fraction is the whole point. The point is to have nothing in the denominator, or at least, I shouldn't say nothing, but 1 in the denominator, which then gives me a term for x without a fraction, right? So 4 times x plus 12 times 1 is 12. And then again, it's going to happen here, right? I'm going to diagonally reduce by dividing out the 4. 4 divides into 4 once. That becomes a 1 on the denominator, and my new numerator is a 3. So now that becomes 3x minus 12. 12 times 1. So now get all my x's on one side. I'm solving for x. I'm going to subtract 3x from both sides. I get 1x plus 12 is equal to negative 12. And then subtract 12 from both sides. I get 1x is equal to negative 24. So there's my answer. X is equal to negative 24. Okay. And I'll show one more check, how to check this, right? Checking is, you're going to take 20, for now I'm going to take negative 24, I'm going to put it in place of x and do the math to see if it works out. So I would have, instead of x over 3, I'm going to have negative 24 divided by 3 plus 1 equals, right? So negative 24 divided by 3 plus 1 equals what? Negative 24 divided by 4 minus 1. So if I check this out, let's check it out. Negative 24 divided by 3 is negative 8. Negative 8 plus 1 is negative 7. Okay, so do I get a negative 7 over here as well? Negative 24 divided by 4 is negative 6. Negative 6 minus 1 is also negative 7. So it checks out. So that's how you check your answer. All right, last one, D. You go to D. D's a little longer here. We've got 9/10 x minus 2 1/10 plus 9/10 equals 2/10 times the quantity 5 minus x. All right, so in this case, I do have some distributive property I need to do. So I'm going to take care of that first. So I'm just going to leave all these decimal values as is because I'm going to end up using decimal busters to get rid of those decimals. But I do have to distill, before I do decimal busters, I have to distribute that 2/10. So in this case, 2/10 times 5, right? 2/10 times 5 is 1. Because if we remember, you multiply 2 times 5 and you get 10. And then in your product, you add a decimal in 1 digit after the decimal place. So there's going to be, the decimal will be right there. 1 digit after needs to be after one digit has to be after the decimal place, just like in your product. And then minus, it's 2/10 times x. So now I've got no more distributive property. This is now when I can apply the decimal buster, and my decimal buster is 10 because every one of these is tenths, right? There's only a single digit past the decimal place. So I'm going to multiply everything by 10, which moves each of these. So normally I would write 10 times that, 10 times that, 10 times that, 10 times that, 10 times that. But I'm going to go ahead and just, in this case, just talk you through it. So it's 10 times that, which moves the decimal place 1. So now it becomes 9x. 10 times this, 10 times 2 and 1/10, moves the decimal place 1. So now it becomes minus 21. 10 times 9/10, move the decimal place 1. So now it becomes plus 9. No more decimals. 10 times 1.0, move the decimal place once. So it becomes just back to being 10. And then last one all the way 10 times 2/10 x. Move the decimal place once. So now it's minus 2x. So now I have a nice equation without decimals. So I can go ahead and do what I normally do. Let's combine like terms over here. So 9x, and that becomes minus, let's see, negative 21 and positive 9, right? Remember that minus in front makes that a negative 21. Gives me a negative 12 equals 10 minus 2x. So let's get all my x's on one side. Add 2x to both sides. I get 11x minus 12 is equal to 10. I'm going to add 12 to both sides. I get 11x equals 22. Oh, I can see it already. Divide both sides by 11. X equals 2. So there we have it. All right. I hope that helped.